Hello and welcome back to the Harrier project. A lot of things has happened the last days. And all about this we want to talk in this video. So we have working on the fuselage. Yeah, we installed a lot of spars and the engines and also the ducting. And as you can see, the vertical and horizontal stabilizers. And then we did a lot of truss testing with different inlets and different ESCs to see which work best on a Harrier. And the next is a very big part, the printing process, especially with the Lightweigt PLA. We did a lot of testing to get lighter and lighter, and this was so amazing what is possible with these 3D printers. Yeah, here we printed, for instance, the horizontal stabilizer again, and we also tested different infills with different % of infill, and the results are so amazing. Yeah, just this for the moment. Yeah, and the next is we built a new part. This is a mixture of composites and lightweight PLA. Yeah, this is the spar. This is the main wing spar. Yeah, and here we did the first test part. Yes, and all these things we want to talk about. So let's get up and we will start how to bring the fuselage in this position. Let's go. So here we got our Harrier fuselage, and the next things are we want to install the attachment for the vertical stabilizer and a lot of other things in this area. And the access is not so good, it's only from this side. That's why I want to cut. That's why I want to cut an opening in here. And I have to make a lot of more cutouts, for instance for the nozzles of the ducting. And you see this fuselage is very shaky. Yeah, so this would be a mess to work on it this way. That's why the first thing is I built a stand, a jig to hold it. Yeah, and my idea is to take this wood, put onto verticals at the ends, and then make some pins at the front and the rear of the fuselage so that it could be rotatable. Yeah, and let's see how it works. Let's go! the fuselage mounting is done. It looks really nice and works perfect. Yeah, it's full rotatable, 360 degree. Here's the rear hatch. This is for rear gear, and here is for the front gear. And I will do the cut out with this oscillating saw. So I would say, let's cut. And right after all these holes are cut into the fuselage, it was time to print the main spar, the main engine spar. This one is made of PLA, and I want to show you how it was created. So now we want to bond these parts to the fuselage. Yeah, we already grinded the surface, and the next step are that we put on some resin and then we fill in the gaps with microballoon. So now we take our bag, our plastic bag, and fill in the microballoon cotton flock mixture. Here we got it. You can see this is our mixture. Mostly microballoons and a little bit cotton flocks for stabilizing it in the bag. And next is cutting off the top of this bag, just a little bit. And next we put first some resin on the bonding surfaces. For this I take a small brush, because they are just small areas. And also here is very important, this is for the gear. Ziggy takes the Harrier out of the oven. So the resin cured overnight, and now the work goes on. So this is how the Harrier was built till now. The next is our truss testing, and there are two reasons why we did this again. At first, we have a very lightweight ESC. This is APD ProShot 120, and this is much more lightweight than the normal one that we use here from JP, 150 amp opto ESC. Yeah, there's a big weight difference. And you know, we have to build up this lightweight, so we want to test it. And the second reason is we want to know the truss difference between the inlet ring that is normally mounted on the JP fan. Then this inlet, this is for closed ducting. And this inlet, this is hybrid between the inlet ring and the closed ducting. Yeah, it is semi-open. Yeah, and we finally want to know which of these inlets or ductings we want to glue into the Harrier. That's why we did this test. And for this, and to see clearly the differences, we have this test stand from JP. And with this, we does the test on 12S, LiPo 5 amp, and here you can see the results. So here we got the new ESC, the ProShot, and we wanna install this, make it a little bit smaller. This is too wide, so we wanna cut it in here. Der ist schon bewegt.
Viereinhalb, ne?
So, jetzt ist so.
Ja.
Yeah, we saw these two inlets perform best in our tests, And finally we decide us for this semi-closed duct, because with this ducting, this is in one hand glued on the fuselage itself, so the EDF can be put in here and this inlet holds the EDF. And the second thing is why we decided us for this is that the air is a little bit guided inside the fuselage. So we think there are less vortices and less turbulences. So then when both EDF are working inside, then we have a better thrust result at the end. The second thing was the tests with these two ESCs. Yeah, and this super lightweight ProShot ESC was overheated. It doesn't get damaged or something like this, but it was getting too hot, so that we can't use this. Yeah, we stay at this bigger one. Yeah, the temperature on this one was quite okay because we got 4000 watt per EDF. Yeah, this is quite a lot power, and we have to be sure that the ESC is working fine, especially while hovering and while the transition. This was the testing on the powertrain. And the next big part is the lightweight PLA printing process. Yeah. You know, this jet will be made two components in the main. One side are composites, and on the other hand lightweight printed parts. You remember the weight of this elevator was about 50 grams, one outer layer. So, and the next we tried is to get lower with the infill and test other infill structures. What I get very familiar with is the gyroid. Yeah, I'm starting to love this. Yeah, this looks absolutely amazing, and most important and much more important is it works amazing. Yeah, here we got it. This is with 10% infill gyroid. Yeah, and this feels like a one-piece part. Yeah, this is absolutely homogeneous surface. Yeah, you can press where you want, and there is nothing where it felt soft and after it felt harder. When we take a look at here, for instance, you see these waves, and this is because these are where the material is free till it comes to the next honeycomb. Yeah, so we have not such a homogeneous surface. Yeah, and this will cause problems, especially when the surface gets warm. Yeah, when we have summer and it gets warm outside. I was heating this till 40 degrees, and these waves appears, and I think here we won't have this. And the next super result is this weighs 10 grams less. Yeah, the weight of this part without resin and anything else is 40 grams, and I want to see what is possible. So I go down again with the infill. This has just 5% infill gyroid, and the weight is again 10 grams less. Yeah, it's 30 grams. Yeah, and this is quite such amazing result. Yeah, with this small little part we can go 20 grams less. Yeah, the stability is quite okay. Yeah, it's still at the moment it's a little bit soft, but when it is covered with resin, I'm sure that it is stable enough. If there has to be some reinforcement, this is no problem to put a carbon roving, 400 hex carbon roving on the surface to reinforce it against bending. Yeah, but it will still be much more lightweight than this, and also the surface is much more homogeneous. Yeah, this is the first part. And the second thing is the main spar, the main wing spar. Here you can see this in a CAD. This should also be printed. Yeah, this should become a hybrid part with a 3D printed core and reinforced by composites. Yeah, in here we will put carbon rovings, and all around we want to put a carbon tube. Yeah. So, and at first I want to show you a little bit of the printing process, that you can imagine how this gyroid looks like, and how the differences between 10 and 5% looks like. Yeah? And then we can go to the laminating process. So let's go. So all parts are already prepared. Here we have our carbon rovings. This is the 3D printed spar part. Here we got our glass tube. And last but not least, this is a shrinking tube. This comes at the last. Now I will pack the rovings to a package. And then they will put in this gap on the top of the spar. Here we have our spar. First I will put some resin in here for good bonding. Yeah, with the spar this works out very nice. I'm very happy with the result. The rovings are exactly where they should be in this small little gap. And this is super stiff, yeah, I can't bend it. I'm working on a test machine, so maybe next video we can see the first stress test, yeah, on these spars. And also this works so nice that a shrink tube isn't necessary, so the next ones will be built without a shrink tube. Yeah, I hope you enjoyed this little video, so that we can see us in the next one. And there I will go on with installing the EDF for yaw. This is the EDF which comes on the tail, yeah, for the yaw control. I also will go on with put in the servo for the horizontal stabilizer. Yeah, and let's see what we can do next. Especially I have to go on with the wing. Yeah, so see you in the next video. Bye bye.